Okay, we are live. So with lesson 5, did you guys have any questions before you want to go on to the quiz, or?
You? Also pretty good on this lesson.
I have a question about how to make a QQ plot. Because if I understand well, we should put the C-scores in the while axis.
Y-axis.
Y-axis.
So, are you talking about the QQ plots?
Yes.
Okay. So if I am thinking of the right ones, I'm pretty sure that's where all the dots have to land on a straight line, pretty much.
Yes. But my question is, how can I create or how can I make the plot manually, because I use the tool Excel.
Oh.
You want to create one in Excel?
But I use the help tool provided by the class.
Yeah.
I don't know if they have a specific QQ plot. I might be talking crazy here, but I think you just do a scatter plot and wait. So it says what's this? Yes.
I'll see if I can make one real quick.
No, it gives you one.
Yeah, I don't know if it'll ever really require us to make one, but maybe.
My question is, the data that is in the x-axis is what is that is in the y-axis?
So I can show you here. If 1 second. Let's see. I mean, I don't know if this is what you're looking for, but I can share my screen real quick. So I think if that's possible. Okay. So do you see this graph?
Yes.
So you have your values, and you have your, this can be your x-axis, and your y-axis is generated automatically based on how big your values are. And if so, what you can do is you can click on here on your x-axis, right click, select data, and then you can tell it which side to go on, basically.
Okay, I think I got it.
So I think that works. Let's see. That didn't work either, actually. Oh, yeah, it did. No, it didn't. I don't know. Anyways, I don't think we'll really have to ever plot it.
We're safe. All right. Want to do this thing?
Let's do it. And are you ready to do the quiz, Chris?
Yes, I'm ready.
Okay. Do you want to read this one, Meryl?
You got it.
Awesome.
Get in there. Sorry, navigate it out for a second. Okay. The total area under a normal distribution curve must equal
¿Ya vas a venir? Está bien, ¿no? Te voy a prender bajito.
I don't remember this. Do you remember this? Right?
The total area for a normal distribution curve is equal 1. Yes?
1? Yep.
Yes.
Yeah. So the total area under distribution curve would be 100% of whatever.
Okay, so 1.
Does that make sense?
Yeah, that makes sense. Okay, under certain circumstances, a normal distribution curve can drop below the x-axis. Which is...
I have never seen that.
That's false.
I think it's
false. But now I'm wondering if I missed something.
no, because if it was false, you would have, or if it was true, have negative values. Yeah, I'm pretty sure it's false.
I am too. Let's just go with that. Okay. A normal distribution curve is symmetric.
True.
Right? It's bell-shaped. Is it necessarily symmetric?
Yeah, it is. I mean, you can fold it in half.
Okay.
Not both ways, but one way.
Well, one way.
What?
Nothing. So this guy says, which of the following elements of the figure represents the z-score? That would be
Sí.
right?
What did you guys say?
Isn't it B? Or is it A?
So I think this is a bad question based on the graph, but I would say, I mean,
Letter C.
the z-score. So basically what a z-score tells you is how many standard deviations away from the mean the value is.
Yes.
And so, I don't know.
I don't understand how it represents the z-score.
Oh, it's C.
Yes. See,
Yeah, you're right, Chris.
Because
So
it the number?
Yeah, so it's the axis is showing 1 standard deviation, 2 standard deviations, 3 standard deviations.
Okay.
I would think.
Okey-dokey. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? We're going B on that one?
I put B.
Same.
Do you guys understand why?
Yeah, I do.
All right.
No, I don't.
So, the area, B represents the area that is
That falls
above.
in the 2 standard deviation.
I'm sorry?
The answer you said is letter B, because the area falls into a standard deviation.
Falls over. You're saying it falls closer to the standard deviation?
In the area of 2 standard deviation.
Right. So yeah, that red line on the right
Yes.
is 1 standard deviation away from the mean, or a z-score of 1.
Yes.
And so you're right. So B, that area is all greater than 1. Does
Okay.
that make sense?
Yes.
Okey-doke. Okay, according to the 68, 95, 99.7 rule, what percentage of the data from the bell-shaped distribution will be within 1 standard deviation of the mean? What percentage?
So it's 0.68.
68. The answer is 68.
Yeah, but you got to put a 0.68, 68%. Does that make sense to you guys? Why?
Yeah.
Yes.
Okay.
I keep typing them as percentages and having to go back and put the point in there.
Yeah.
Okay, suppose that z-scores come from a standard normal distribution. Use the normal probability applet to answer this question. What proportion of the z-scores will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places. Okay.
This is a question.
What proportion of the z-scores? Does that mean percentage or what?
Proportion of the z-scores? Is it?
So they,
I
I do
think
not
it's
understand this question.
0.6827. Is the complete number for the 6/8 of the rule.
Okay.
If you put 1 deviation into the normal probability applet and you see the area is 0.6827.
So basically, this is the exact same question as question 8.
oh, it just wants a longer.
So 0.683, right?
Suppose that z-scores come from a normal standard distribution. What proportion of the z-scores will be between -2 and 2?
0.95 something.
0.9546.
5, 5. You good on that one?
Yep.
Okay. Now, what proportion come from -3 and 3?
0.997.
997. Okay. Look carefully at your answers to the last 3 questions. What do you observe? Values match the 68, 95, 99.7 rule. As the z-scores increase, the area between negative and positive decreases, or the probabilities double as you move from 1 to 2. E numero uno, right?
What'd you say?
I'll be number 1.
Yep.
The values match the rule.
Yep.
Sorry? Yeah, they match the rule. What a surprise! Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. Population mean protein requirement for adults is 0.65, yada yada, and the population standard deviation is 0.07. Jeez, okay. What proportion of the population have a protein requirement that is less than 0.60? There.
Alright.
We got 0.65 and 0.07. So I'm slightly confused on this one.
Okay. Give me 1 second and hopefully I can help you out.
Hopefully.
So I don't know if we even got taught this. Did you guys learn about the norm as dist functions in Excel?
The what functions?
Norm S dist.
No.
No.
I know they're just sample function. Is it pretty much the same?
Okay, well, let's see.
In the chapter, should I just look at it?
You know, I don't remember seeing it, but I've already taken business statistics. Just, it wasn't called business statistics. It was called Business Fundamentals 2. And so now I have to take it again because grad school will require me to have one that's called business statistics. But
Oh my gosh.
anyways, I'm sure we'll learn about it eventually. Did you guys come up with an answer at all, or should I just show you what I came up with and we can decide if it's reasonable?
Will you just tell me how you got there? Because I'm a little stuck.
So first I find the z-score
Okay.
Of 0.6.
Points.
And then there's a function in Excel called norm S dist. And that will turn a z-score into a percentage of that is on the left side of the distribution of that z-score. If that makes any sense.
So wait.
But I kind of want to do something.
The zip code is 771.
Sorry, what did you say?
The zip code is 71.
The z-score
Yes.
is negative 0.71.
Negative 0.71.
Yep.
Minus.
So what is the cumulative?
Cumulative.
Well, your function asks for a cumulative.
It shouldn't. It's
Norm.s.dist.
norm.s.dist. Cumulative. Okay, just don't put the dots in there. Just put norm s dist. It'll tell you it's wrong, but it's not. Promise.
So 0.238.
Yeah.
Aren't you a wealth of knowledge? I love Excel.
I don't know about that. So, if you were going to ask me how to calculate that, I'd have no idea because we were just did everything in Excel in my last class. But
Looks like I gotta study that for the test then, for my homework quiz. Okay, what do you think, Chris?
Sorry, what was the answer you said?
0.239.
1, 2, 3, 9. Let me see.
I put 0.238.
Oh, really?
Yeah. I got 0.2375.
Oh, mine says 0.238852. Or so did I get the
What was
standard deviation wrong? Or the
what's your z-score?
the z-score? I put in negative 0.71.
Okay. Yeah, I have negative 0.71429.
Okay, well that completely changed the yes. You're right. My bad. Okay.
Hopefully we don't submit this and that's completely wrong what I just said.
Well, I'm gonna blame you completely. So
All right. I'll take
that
it.
on record.
So were you able to get that? Or?
Sorry, could you please repeat the answer?
So 0.238.
1, 2, 3, 8. I calculate different answer.
What answer do you get?
0.598.
0.598.
So how'd you get there?
How did you come up with that answer, Chris?
Because as you said, we calculate the z-score, and then I substitute this in the equation. To z-score is z-score equal the value x minus the mu. That is the letter for the media of population, between divided by sigma, that is the standard deviation, and we resolve for x.
So, right, so that's to get the z-score. That's a z-score equation.
Yes, then I substitute the value of z-score in the formula, and then I solve for x.
Yeah, I don't know. The only reason I would say that no is because we're less than half. So the mean is 65 and we're at 60. And so our answer has to be less than half, if that makes sense. And 0.59 is more than half.
Okay.
So what equation are you plugging the z-score into?
.60 minus 0.65 divided by 0.07.
Okay. So, yeah, and then that gives you negative 0.71, right?
Yes.
And then what did you do with that number?
What?
So is that the answer that you came up with?
What was the answer I said?
So that's the z-score that you came up with right there. Did you is that what you think the answer is, or did you do something else?
I then substitute in the formula the value of the z-score, and then I solve for x in the formula.
Okay, yeah, I don't know. That second part I don't quite understand, but I guess maybe we can continue on, and if we get this one wrong, then we figure it out.
Okay.
But I'm pretty sure the answer is 0.238.
Okay, so we are trying with the answer 0.238.
Yeah.
238.
If you
That's
want,
what I'm gonna go with.
if you want, I can submit it first and then tell you if it's right or wrong.
Okay. Question 14. What proportion of the population have a protein requirement that is more than 0.6 with 3 decimal places?
Okay. So, did you guys? I have an answer. Do you guys want me to tell it to you or?
Yes, sir.
Yeah, 0.762.
Oh, that's not what I got. Let me do that again. Oh, okay. 0.762. Okay.
So I just take 1 minus what is less than 0.6, which is the 238, hopefully. And that's what's above. Does that make sense?
This, I was using the wrong number. How about you, Chris? Are you comfortable with that answer? Or just turn on it.
I don't understand.
So we just took our last answer and subtracted it from 1 because we went off the basis of 0.6.
Okay, I got it.
So yeah, so that's where we get our
So
7.62.
is the difference between 1 and 2.238?
Yeah, so 1 minus 0.238 is how you arrive there. Okay, question 15. What proportion of the population have a protein requirement that is less than 70%? 0.7, such and such, I mean.
Yep.
So do we have to redo that whole equation and then get the 0.7? Or is there a shorter way to do that?
Well, what I did is I just changed the value to 0.7 instead of having it to 0.6, and my formulas
Oh, you
automatically
like
updated.
Okay, well, I'll just do that. We're gonna do it. Are you with us, Chris? Or would you guys mind if I ran to the bathroom? Because it's been like an hour and
That's fine.
Thank you.
Let me know if you have any questions, Chris.
Mm, I don't know how you calculate the answer with the function in Excel, like you said. But
Question 13.
what was the function you used?
For what question are you talking about?
Yeah, the function you use in Excel to calculate question 13 and 14.
Okay. So there's a function in Excel. It's called norm s dist. So what that does is it changes a z-score to a percentage.
Okay. So the answer for question 15, we are in question 15.
Let's see. Do you want to wait for her before we move on, or do you want to just go?
No, we wait.
Okay, I'm back.
All right.
Where are we?
We didn't move on. So I don't know. Where are you guys at? Do you have 16 done?
Do I have 16 done?
Yeah.
No. So find the probability that a random between 0.6 and 0.7.
Yeah.
Okay. Did you guys discuss this already and I'm just behind?
No,
Okay.
I just did it already. So if you have questions, let me know.
Did you do it in Excel?
Yes, I did.
Can you alter the existing formula for that, or did you do a whole new one?
I remembered the past formula, but so you want me to tell you how I do it?
That'd be great.
Okay. So basically, with the value of 0.7, you find the percentage below it, right?
Yes.
And then you put in the value of 0.6
Yes.
and find the percentage below that and subtract that from the value that's below 0.7.
Okay.
Does that make any sense at all?
It does. It makes a lot of sense. So I would just teach you something else. Point. off thinking it's 0.032. Is that wrong?
Let's see, we're on 16. Yep, that is wrong. So I just submitted the quiz.
Okay.
So I can tell you all the answers,
Okay.
and I can tell you one we missed. Well, I missed.
Okay. So what one did we miss?
So you might not have missed this, but I missed question 8. And the reason being is because it wants it as a whole. Like, remember how I told you not to do this? But
Oh,
it doesn't want it as 0.68, it wants it as 6/8. So
okay.
if that makes sense.
But everything else was okay?
But everything else I got right.
Okay. So 0.16 was right? Or what was question 16? The one we're on. Is that?
So I have 0.525.
Gosh, how am I getting it so wrong? I can do it again on my own time. Sorry. It's insanely long call. And find the 35th percentile for protein requirements for adults, which I would find.
Do you have any questions, Chris? How are you doing?
Yes, I don't know how to calculate the percentiles.
Okay. You guys want me to teach you another nifty trick?
Yes.
Okay. So this one is called Norm S Inv.
With no dots.
With no dots. So I'll share my screen real quick. So what Norm S Inv does is, so the first one's 35%, right? What it does is it takes a percentage and tell you what the z-score of that percentage is.
Oh.
Oops, I shouldn't have done that. Does that make sense?
Yeah, so
But once you have the z-score, you can times that by the standard deviation. Your 0.3, your negative 0.38 standard deviations away from the mean.
huh?
So if you times that by the standard deviation, it gives you the value away from the mean. And then you just subtract that from the mean.
Okay, which is your 0.623 or whatever. Okay. So RS int. Okay, that makes sense. All these cool Excel tricks.
Did that make any sense, Chris?
Mm, sorry, no.
Okay. I wish I knew how to do this without just using the formulas,
Yes.
but I don't. So what you can do is you can turn the percentage into a z-score,
Okay.
and if you use the norm sinv, like I have on my screen, formula, that will give you the z-score.
Okay.
And so z-score is how many standard deviations away from the mean of
Yes.
percent it is, right? And so if you take that z-score times the standard deviation, it will tell you we are, whatever we're talking about, we're negative 0.026 away from them. That
Okay.
makes sense?
Yes.
So then you just take, so the mean is 0.65. So we're 0.026 less than that. So you just subtract that, and that's what the answer is.
Okay.
Okay, so for the 80th percentile, I would subtract the 0.842 from the standard deviation, or the opposite of that.
So let's see. Subtract the 0.42.
0.842, so the z-score.
So you would need to multiply the z-score by the standard deviation.
Oh.
Does that make sense?
Yes.
Yeah. Mean, so 0.0. Okay. So 0.089, right? Is that wrong? I'm wrong.
Yeah, or 0.0589.
0.0589, okay. Which is what I have, I'm just reading it wrong.
Okay.
How I roll. Okay. 0.588.
So you'll need to add that to the mean. Yeah.
6, 5. So 0.709.
You got it.
Okay. Okay, well that actually makes sense to me.
That one made sense?
Yes.
Yes.
Yeah.
I don't know why, but I understand the procedure.
Okay. Let's do this. Are you ready, Chris? You good?
I missed the question 15.
Question 15.
Okay. So that one,
Okay.
let's see.
Sorry, my computer's freezing.
Do you want me to show you how to do that one? Chris?
Yes, please.
Okay. So I'll start over.
Okay.
So right here we have the values, right?
Yes.
So first we need to find the z-score. So that equals our value minus the mean divided by the standard deviation, right?
Yes.
Okay. So I don't know if this is the way our teacher wants us to do it, but it's the easiest way. So if you go equals norm S dist, ask for a Z for the Z score and you put it in there. That's telling you that below there's 76% of, what are we talking about here?
Below 70.
Gram portion of the positive protein requirement. So 76% of the people require less than 0.7 grams of protein.
Okay.
So do
That
these
makes sense.
questions want it as the decimal or as the whole number?
So I think, let me double check here before I tell you wrong. Every answer is in decimals except for question 8.
So the function gives me the answer, basically.
Yeah.
Yep. Yep. So, I mean, you guys can learn them if you want, but these are the functions that are lifesavers.
Yeah, no kidding. They're super cool.
Norm in. So those 4 right there will take care of a lot of hassle.
I'm sure I don't know these functions even in Spanish.
Yeah, they should. Is your Excel in Spanish?
Because I learned in Excel in Spanish, but I'm sure I don't know these functions.
Okay. Distribución normal. Distribución S normal.
Well, that was fun. All right, are we good here?
I'm good.
Well, great. Then I think I'm gonna go eat dinner.
All right. Thanks, guys.
Thank you, and you, Chris. And we'll see you next Tuesday, 7.
Next Thursday? Yes.
Okay,
Perfect. Thanks, guys. Bye.
bye.